All right, welcome back. So with 1.3, still working in pre-calc, this is going to be showing us a little bit more about functions and their graphs. Towards the end of this section, we'll be looking at actual graphs, but leading up to it, we'll see a little bit of algebra. We will also see a little bit of calculus. We won't get too much into how this is shown, but this difference quotient will be seen in calculus and then taken a little bit further. So if you're going into calc later on down the road, this might be something that you see again. But the first few objectives, identifying intervals where it's increasing, decreasing, or constant, this will be pretty visual for us. Using graphs to locate the relative maxima or minima, similar to maximum and minimum. You could probably make an understanding of that based off of the first three letters in these vocab terms. Identifying even or odd functions and recognizing their symmetries, so how they move, how they look, how they're progressing as they move to the left or to the right. Using and understanding piecewise functions. This is a little bit of algebra 2, where you might have seen it there. Also finding and simplifying the function's difference quotient, which is what we're doing here. So again, this is going to be teetering towards calculus, but we won't get too much into the actual calculus idea. So they're asking us to find and simplify the difference quotient. They have this fraction here where f is using x plus h. We're subtracting the original f of x function. So f of x, we see that this is derived down here already. So we'll kind of be copying and pasting that in. And this is all being divided by a constant h, where just for saving themselves the trouble, they say that h cannot be equal to 0. And this is our function of x, negative 2x squared minus 2x plus 3. So this does look intimidating at first. If you look closely, we have two things that we really need to evaluate: f of x plus h and f of x, and then eventually dividing by h. So if we take this f of x further, we might want to just practice denoting what f of x plus h is going to be. So we're taking wherever x is, keeping in mind to use parentheses because this is a binomial. Rewriting x plus h, subtracting the x, where now this is x plus h because this is what the input is for this function. And then also adding 3. We might notice in here that we have this binomial x plus h being squared. If you need some assistance with breaking this part down further, you can use box method. But for this one, I'm just going to jump ahead. So I know that we have negative 2 leading the front. When this binomial x plus h is squared, we end up with x squared plus 2xh plus h squared. Keeping this all in parentheses because we have that negative 2 towards the front. If we're then subtracting x plus h, I'll distribute that. So subtracting x, continuing to subtract h because we're distributing that, then finally adding 3. So you might be saying to yourself, this looks as if there is a lot going on, and there is for sure, but hopefully you can see that we have this constant negative 2 out here towards the front with parentheses of this trinomial in here. So channeling some algebra skills, we'll distribute that negative 2 to break this down. We then are left with negative 2x squared. Negative 2 times this 2 gets us negative 4. X and h are along for the ride. We're then subtracting 2h squared, keeping in mind that we have this negative x minus that h plus that 3, continuing with this. If we double check, there are no common terms here. We see that there's an x squared term. There's no other x squared term. We see x multiplying with h, no other xh term. We have h squared. We have x on its own, h on its own, and then that constant of 3. So a lot is going on here. And I think this is the most challenging part of this problem, just evaluating that f of x plus h. But once you have this done, it's as if we're taking this back to the main difference quotient formula that we have up here. So if we take all of this and start to rewrite this quotient here, rewriting as is, we have negative 2x squared minus 4xh minus 2h squared minus x minus h plus 3. So this is that f of x plus h portion. It's then telling us to subtract f of x, which is already given to us. So we're subtracting this negative 2x squared minus x plus 3, keeping in mind this entire fraction is divided by h. As you can see here, there is a lot going on. There's so much that I even need more space. So no shame in that. Let's get another piece of paper. And we're continuing to evaluate this. So down here, we know that we're subtracting this trinomial. So if you want to rewrite that as plus 2x squared from distributing, plus that x minus that 3. I'll even rewrite f of x plus h. This is probably the most amount of math work that you've had for one problem. So if this seems intimidating, we're almost done. We'll just rewrite that this is dividing by h, just for closure. And since we distributed this idea of -1, subtracting this trinomial here, now it's going to be a matter of what we can combine. So we see that we have an x squared term seen at the beginning and towards the end. We also see an x term that was towards the end of x plus h, and also towards the end here. We'll soon see some cancellation. If we also look closely, we also seem to have constants of this +3 and this -3. So if we begin to combine like terms, we see we have a -2x squared, +2x squared. We're lucky these are going to cancel. If we focus on the x terms, -x and +x, those cancel. And we'll make a note here. So when you're combining like terms, you should see a lot of cancellation, because we only want to be left with so many terms. So it's good that we're seeing a lot of these terms cancel, concluding with the 3, +3 and -3, those cancel. If we rewrite this, we're left with that -4 xh minus 2h squared, and there's nothing else left, so we're in good shape. Keeping in mind this is all divided by h. And you might start to look at this fraction seen here. You might start to notice that there's a pattern where hopefully we can see all 3 terms in here, the 2 terms in the top, 1 in the bottom. What do you think they have in common? Hopefully you're saying that they share h. So since all of these terms share h, we can factor out h, which is totally fair game. That's what we want to do. If we factor out h from the top 2 terms, we have h on the outside of -4x, subtracting now just -2h. H is towards the bottom. Since we have h outside factored out in the top, h in the bottom, these can cancel. We can then rewrite this just with what's left, -4x minus 2h. There's nothing else that we can combine from here, so we're good with that. I also forgot this -h here, so let's also keep that in check. My apologies. We'll keep that. If we factor this out, this is deducting 1. Sorry about that. So let's actually rewrite this so we know what our real answer is. So negative 4x minus 2h minus 1, just so that we're combining what they mentioned at the beginning, saying h cannot be equal to 0. This is going to be our difference quotient seen here, negative 4x minus 2h minus 1. Eventually in calculus, you'll be able to knock out problems that involve derivatives, and this is really just showing you how it will be done. So tinkering on calculus, but nothing crazy.